So let's start in the upper left here. Obviously, we got the fraction bar here, which tells us we have to do everything on top first. Oh, it is a little carried away. I wouldn't add, if I asked something like this on a test, it would be extra credit. Which is a hint that I might ask an extra credit question, something like this on a test. Just so you know. So on the top here, we got 10 to the 8th times 10 to the 5th, which would be, that combines to make 10 to the 13th. Very good. 8 plus 5 is 13. On the bottom of that piece, 10 to the 3rd to the 5th power is 10 to the 15th. 3 times 5 is 15. Now I'm going to divide those two. 10 to the 13th divided by 10 to the 15th is 10 to the negative 2, right? So let's come over here. 10 to the 9th times 10 to the negative 3, 10 to the 6th. 10 to the negative 8th times 10 to the 2nd, 10 to the negative 6th. We combine those, 10 to the 6th divided by 10 to the negative 6th, 10 to the 12th. Now I can combine those two, 10 to the negative 2 times 10 to the 12th. That's 10 to the 10 on top of that one. That, what we finished there, is this whole piece right here. So now we'll come down here. 10 to the 6th divided by 10 to the negative 4th. 10 to the 2. 10 to the negative 3 divided by 10 to the 5th. 10 to the negative 8.
Wait, wouldn't that one be 10 to the 10?
Here?
10 to the 7?
Oh, you're right. You are correct. Thank you. 6 minus negative 4 will be 10. Very good. So 10 to the 6th divided by 10 to the negative 4th will be 10 to the 10th. So we got 10 to the 10th times 10 to the negative 8th is 10 to the 2nd. 10 to the 2nd times 10 to the 3rd, 10 to the 5th. This whole thing will divide to give us 10 to the 5th. 10 to the 10th divided by 10 to the 5th, 10 minus 5 is 5. So this whole thing here is 10 to the 5th. Let's look over here. So over here, sorry. So over here we got nothing to do on top. That's 10 to the 7th. On bottom we have 10 to the negative 5th times 10 to the 3rd, which is 10 to the negative 2. So then we combine 10 to the 7th and 10 to the negative 2. 10 to the 9th. Yes, 7 minus negative 2 is 9. Over here, 10 to the negative 3rd divided by 10 to the 6th is 10 to the negative 9. 10 to the negative 9 times 10 to the 5th. Negative 4. Negative 9 plus 5 is negative 4. To the power of negative 3. I gotta do the power first. I've already combined the negative 9 and the 5. That's where I got the negative 4. The negative 4 is all that's left inside here now. So, oh, he is. He's trying. 10 to the negative 4 then. 10 to the negative 4 to the power of negative 3 is 10 to the positive 12. Negative 4 times negative 3 is 12. And we then have 10 to the 9 times 10 to the 12 is 10 to the 21. So that's the top of that. Over here, 10 to the 8th times 10 to the negative 3. 10 to the 5th. And over here, 10 to the negative 5 divided by 10 to the negative 11. Negative 5 minus negative 11 is negative 5 plus 11, or 10 to the 6th. 10 to the 5th times 10 to the 6th is 10 to the 11th. 10 to the 21 divided by 10 to the 11th. 21 minus 11 is 10, so that's 10 to the 10th. So that whole section over here becomes 10 to the 10th. That's going to multiply. It's going to give us 10 to the 15th. So the whole top is 10 to the 15th. Come back down to that. Let's work on bottom here. Over here, 10 to the 6th times 10 to the negative 9th. Everybody at once. 6 plus negative 9. Negative 3. 10 to the 5th squared.
10 to the 10th.
10 to the 10th. Good job.
Oh, Cody with them snap hands.
10 to the negative 3 divided by 10 to the 10th. Negative 3 minus 10 is 10 to the negative 13th for that.
Messing up here.
Now over here. 10 to the 3rd divided by 10 to the negative 4. 7th. 3 minus negative 4 is 7. Times 8. Or times 10 to the 8th. That's 10 to the 15th. Divided by 10 to the 15th divided by 10 to the 7th. 10 to the 8th. 10 to the negative 13th times 10 to the 8th is 10 to the negative 5th. So this whole section here becomes 10 to the negative 5th. Over here, 10 to the 4th times 10 to the negative 8th. When I'm multiplying, I add powers. 4 plus negative 8 is negative 4. To the power of 3, I multiply powers when I do a power of a power, so negative 4 times 3 is negative 12. Over here, 10 to the 8th divided by 10 to the 3rd. When I divide, I subtract powers, so 8 minus 3 is 5. 10 to the 5th to the 4th power is 10 to the 20th. Good. So now I have on top there 10 to the negative 12 times 10 to the 20th. That's going to be 10 to the 8th on top. Negative 12 plus 20 is 8. On bottom, 10 to the negative 7 times 10 to the 5th. Negative 2, I add powers. To the power of negative 4, 10 to the positive 8. What is 10 to the 8th divided by 10 to the 8th? If I subtract, 8 minus 8 is 0, right? It's 10 to the 0. Or just 1. Cancels out. But it's easier if I leave it as 10 to the 0 here for now. So now on bottom, I have 10 to the negative 5th times 10 to the 0, which is negative 5 plus 0 is negative 5. So 10 to the 15th divided by 10 to the negative 5. Negative 15 minus negative 5.
No problem.
10 to the 20th. Anybody get that right? No, there's a lot. I know there's a lot of processes there. Yeah, I could have. On a test, it'll be a lot simpler. I would never have more than like 3 or 4 steps on a test. You know, maybe on a test, I'd maybe have something like this. That's about as far as I'd ever go on a test or something like that.
You do that by your head right now?
Okay, so we left off talking about our operations with scientific notation. So the next step I want to take is something like this. (2.4 times 10 to the 7th squared). When I square a fraction, if you recall, if I had 3/4 squared, remember I split it up and I did the count separate and then the name, right? We did 3 squared and then the 4 squared, because it's 9/16. If I go way back, if I did like 5 inches and I had to square it, I did the same thing. I did the count separate. What's 5 squared? 25. Then I squared the name. Inches squared is inches squared. So when we square a number, we take a number to a power, we apply the power to the count, and then we apply the power to the name. So here, 2.4 times 10 to the 7th squared, or to the power of 2, I'm going to do 2.4 squared, and then I'm going to do the 10 to the 7th squared. So 2.4 squared is 5.76. I'm hoping at this point you guys all know how to enter that in your calculator, using either the caret key or the x squared key, right? Or you do 2.4 times 2.4. You look confused. Okay. How about 10 to the 7th squared? What's that going to be? A power of a power. What do we do with the powers? Times. 7 times 2 is 14. 10 to the 14th. Very good. What if I have 7 times 2? So what if I have 1.2 times 10 to the negative 8 to the power of 3? Well, again, I separate it out. It's going to be 1.2 to the power of 3 times 10 to the negative 8 to the power of 3. 1.2 to the power of 3 is 1.728 times 10 to the negative 8 to the power of 3, negative 24. Very good. What's that? Okay, so let's say we have 1.6 times 10 to the 11th to the power of 4. What are we going to do there? Take 1.6 to the power of 4. 6.5536, okay. Then you take the 10 to the 11th to the power of 4. 11 times 4 is 44. You got it, 10 to the 44. Any questions? Do this one in your notes for me quick. See if you got her. Okay, so 3.5 to the power of 5. What do we get? Hey guys, we gotta keep it down. 525.2. We're around 0.22. 525.22. That's fine. You're good enough. Times 10 to the power of negative 25. Now the decimal point here has to move 2 spots over. 5.2522. Now this number got smaller by 2 places, so the power has to get larger by 2. So negative 25 plus 2 is negative 23. What you think? Not horrible? Okay, now we've learned the scientific notation. There's something out there called engineering notation. In engineering notation, there's some extra limits put on it, and there's some things that are some rules that are loosened up. Unlike scientific notation, we can have more than 1 digit in front of the decimal point. So we don't have that restriction. But our powers of 10 are limited to multiples of 3. So like 0, 3, 6, 9, 12, negative 3, negative 6, negative 9, and so on. So what that means is if I have something like 260,000, and I want to put that in engineering notation, we have to move the decimal point 3 spots at a time. So I go 1, 2, 3. Can I move it 3 more? No, I have to, in engineering notation, I have to have between 1 and 3 digits in front of the decimal point. If I went 3 more, I wouldn't have any digits in front of the decimal point. So that's 260 times 10 to the third, because I could only go 3 spots. It's a little more confusing going the other direction. So 0.00053, if I go to put that into scientific notation, I go 1, 2, 3 spots. Can I go 3 more? Your first instinct is to say, no, I can't. But we have to. Right now, there's no non-zero digits in front of the decimal point. So I have to go 4, 5, and add a 0 to get 6. So that's 530 times 10 to the 6th. So the question, or times 10 to the negative 6, I should say. So the question comes out, why would we do this? Why do we want to limit this? Well, because when we do metric measurements, our metric prefixes are engineering notation. We'll look at these more next week, what our measurement units are, but if you have meters, then you go to centimeters, or not centimeters, sorry, millimeters, and micrometers. Go kilometers and megameters. The main unit is 1, or 10 to the power of 0. Milli is 10 to the negative 3. Micro is 10 to the negative 6. If you are in electronics, you might have nanovolts or nano coulombs for some capacitors and stuff like that. Kilometers, kilo is 1,000 or 10 to the 3rd. Mega is 1,000,000, so 10 to the 6th. If you kept going, you have giga, which is 10 to the 9th, and tera, which is 10 to the 12th.
What's centi?
Centi is 100th, but we're not going to use that here. That's actually a extraneous unit that only gets used for certain measurements. I'll show you. We'll learn that next week. So you see here, the powers of 10 here are all multiples of 3. 0, 3, 6, negative 3, negative 6. So if I'm doing an operation, let's say one of the formulas we saw in Unit 1 was that voltage is equal to current times resistance. If I have that my current is 3 amps and my resistance is 7 ohms, well then this isn't that hard to do. My voltage is just 3 times 7, which is 21, and I put the appropriate units on it, which is volts. But it usually doesn't work that way. Normally what we'll have is current is given as 6 milliamps, and resistance is given as 40 kilo ohms. So to find my voltage here, 6 milliamps times 40 kilo ohms, this becomes a problem in engineering notation. So 6 milliamps. Milli was what power of 10 again? Negative 3. This is 6 times 10 to the negative 3 amps. Times 40 kilo was 10 to the positive 3 kilo ohms. So now we multiply. 6 times 40 is 240. 10 to the third times, or 10 to the negative third times 10 to the positive third is 10 to the 0. And an amp times an ohm is a volt. Well, 10 to the 0 means that's just 1. So this is just 240 volts. So the engineering notation allows us to work with our metric prefixes. We might have power, which is one of the things we use for power is voltage squared divided by resistance. So let's say our voltage, we have a large voltage of 2.1 times, or 2.1 kilovolts. And we have a resistance of, let's see here, 430 giga ohms. So now what's going to go on top of this? 2.1 kilo is 10 to the third. That's going to be squared. On bottom here is the 430. Giga is 10 to the 9th. So we've got 2.1 squared is 4.41. 10 to the third squared is 10 to the 6th. On bottom, we've still got the 430 times 10 to the 9th. We'll divide. 4.41 divided by 430. Is 0.0103 times 10 to the 6 divided by 10 to the 9th is 6 minus 9 is negative 3. Now, of course, we can't leave it that way. We're going to move our decimal point. We have to go 3 spots at a time. 1, 2, 3. So that'd be 10.3. The number got bigger, so the power of 10 has to get smaller. got bigger by 3, the power of 10 gets smaller by 3. 10 to the negative 6. Negative 6 is micro, so that's microwatts. 10.3 microwatts of power. I don't expect you to understand the watts, the volts, and the ohms and all that stuff right now, but you can see the metric prefixes play in there with the engineering notation. So now you know how to take the power of a number in scientific notation. So that should finish off everything you need to know. So still continue with page 130. We're going to add to that page 133. Exercise 2.7, 1 through 23, the odds. I'll give you guys the last 16 minutes here to finish up from the first hour and get a good start on this homework.